Hello, welcome to Lucky Coin channel. Today, let's talk about 3 features of blockchain: decentralization, transparency, and security. First, let's talk about blockchain decentralization. A blockchain allows the data in a database to be spread out among several network nodes at various locations. This creates redundancy and maintains the fidelity of the data. For example, if someone tries to alter a record on one node, the other nodes would prevent it from happening by comparing block hashes. This way, no single node can alter information within the chain. Because of this distribution, the blockchain data, such as transaction history, becomes irreversible. Such a record could be a list of transactions, but private blockchains can also hold a variety of other information like legal contracts, state identifications, or a company's inventory. Most blockchains wouldn't store these items directly. They would likely be sent through a hashing algorithm and represented on the blockchain by a token. The second feature of blockchain is transparency. Because of the decentralized nature of the Bitcoin blockchain, all transactions can be transparently viewed by downloading and inspecting them, or by using blockchain explorers that allow anyone to see transactions occurring live. Each node has its own copy of the chain that gets updated as fresh blocks are confirmed and added. This means that if you wanted to, you could track a Bitcoin wherever it goes. For example, exchanges have been hacked in the past, resulting in the loss of large amounts of cryptocurrency. While the hackers may have been anonymous, the crypto they extracted is easily traceable because the wallet addresses are stored on the blockchain. Of course, the records stored in the Bitcoin blockchain, as well as most others, are encrypted. This means that only the person assigned an address can reveal their identity. As a result, blockchain users can remain anonymous while preserving transparency. Security is blockchain's third feature. Blockchain technology achieves decentralized security and trust in several ways. To begin, new blocks are always stored linearly and chronologically. That is, they are always added to the end of the blockchain. After a block has been added to the end of the blockchain, previous blocks cannot be altered. A change in any data changes the hash of the block it was in. Because each block contains the previous block's hash, a change in one would change the following blocks. The network would generally reject an altered block because the hashes would not match. However, a change can be accomplished on smaller blockchain networks. A new and smaller chain might be susceptible to this kind of attack, but the attacker would need at least half of the computational power of the network. On the Bitcoin and other larger blockchains, this is nearly impossible. By the time the hacker takes any action, the network is likely to have moved past the blocks they were trying to alter. This is because the rate at which these networks hash is exceptionally rapid. The Ethereum blockchain is not likely to be hacked either again. The attackers would need to control more than half of the blockchain's staked Ether. As of September 2024, over 33.8 million ETH has been staked by more than 1 million validators. An attacker or a group would need to own over 17 million ETH, be randomly selected to validate blocks enough times to get their blocks implemented. Thank you for watching. If you enjoy our content, please remember to subscribe our channel.